Hello, Psych 101 students. Welcome to Module 4, Learning Objective 10. We will look at biology and cognition in operant conditioning and learning by watching others. Okay, so behaviorists such as B.F. Skinner believed, believed that all behavior could be explained by conditioning principles. All behavior. In reality, reinforcement explains only a certain amount of human behavior. Biological factors can either increase or limit the effects of reinforcement on learning, and learning can occur without reinforcement. So these last 2 points here are you know going against the idea that all behavior is explained by conditioning principles. So let's take a look at how biological factors can affect reinforcement and the reinforcement on learning and the effects of reinforcement on learning, excuse me, and how learning can occur without reinforcement. Uh, so we're going to start with some biology here. And dopamine, as you know, is a neurotransmitter in the brain, and it has a biological influence on how reinforcing something is. I'm going to skip down to the final point and start there. Liking and wanting something are tied to dopamine and endorphins. For example, dopamine is released when you eat or drink, and the hungrier or thirstier you are, the more dopamine gets released in your system, which is why food tastes better when you are hungry, and water is so delicious if you're really thirsty. Um, so the more dopamine that gets released, the more you like and want something, and the more rewarding it is. Um, Drugs that block dopamine's effects disrupt operant conditioning because things are no longer as reinforcing as they used to be. So if things aren't reinforcing, then operant conditioning doesn't work properly. Drugs that enhance dopamine activation, such as cocaine and amphetamines, they increase the reinforcing value of stimuli. So you might have heard that some people crave snacks when they're high, um, and it's because food becomes more reinforcing under these conditions, because dopamine activation is increased. So this is just showing that like your biology of your neurotransmitter biology is affecting has a lot of effects on operant conditioning. It can disrupt operant conditioning. It can make it more rewarding. So operant conditioning doesn't happen in a vacuum. Other things are affecting it constantly. Um, and here's another example. Some animals are hardwired. So some animal behaviors are. I'm a little tired. Sorry. Some animal behaviors are hardwired, and it's difficult to learn behaviors that are counter to evolutionary adaptation. Conditioning is most effective when matched to the animal's biological predispositions, but animals have a hard time learning behaviors that go against their biological predispositions. For example, raccoons are hardwired to rub food between their paws, as this raccoon is doing in the picture. It's just something they do, it's in their genetics. Um, they have trouble learning not to rub objects together if those objects represent food to them. So, as you may have read in the book, they were trying to, for purposes of a commercial, they were trying to teach raccoons to carry money, little coins, and drop them in a piggy bank. but which is a behavior they could teach various animals to do, but not the raccoons, because the raccoons were being rewarded, for their behaviors with food. And what happened was that classical conditioning kicked in, and the coins that they were carrying came to represent food to them because they were being paired with food. Because whenever they performed the behavior, and apparently they were okay dropping one coin into the piggy bank, but if they were carrying two, they would just start rubbing them together. And they basically kind of ruined the whole commercial, and they couldn't get them to carry two coins at a time and put them in the piggy bank without them stopping to rub them together. Um, and this, so once again, it's like not everything can be conditioned. Not everything can be operantly conditioned, because some things will go against the genetic codes, or the hardwired behaviors that are within certain animals. Um, Another challenge to the idea that reinforcement is responsible for all behavior is the fact that learning can take place without reinforcement. And there were, there people like Skinner especially was a real hardliner. He believed that all behavior could be explained by operant conditioning and by the reinforcement. We increase certain behaviors because we get reinforced, and we decrease others because we get punished. And he thought this explained all of our behaviors. But if to demonstrate that learning can occur without reinforcement goes against his ideas that you can explain all behavior by that. So let's look at this example here of learning without reinforcement. Um, Edward Tolman, he ran rats through complex mazes to obtain food. He believed that during an experiment, each rat held in its brain a representation of the particular maze. This representation is known as a cognitive map. It's a visual, spatial, mental representation of environments. We all carry cognitive maps around in our brains, especially of well known places, or well-known neighborhoods, or things like that. Like, you know, for if you have to, if you had to walk to a store or something, like, you can picture the route that you would take, or if you had to drive there. I mean, you can picture it in advance because you have a cognitive map. You don't have to look up, you know, map system every time you drive somewhere. And the cognitive maps include things like the insides of buildings. So if any of you have spent time, a fair bit of time around the MCC, I'm sure you could make your way from, I don't know, from, let's say, the library to the front doors, or whatever. I mean, you can picture it in your mind, the route to take. That's what a cognitive map is, and we all form them of many well-known places that we spend time in. And this is what Tolman said. He said the rats do this. He believed rats form cognitive maps as well. The reason this is important is that cognitive maps is an aspect of thinking. It involves cognition. I mean, the behaviorists, didn't think that that thinking was involved in learning. We happen to have these brains that can do calculations and think about things, but what Skinner and others believed was that it was our thinking processes were really irrelevant to learning. We were learning automatically, just um, due to conditioning principles. So to demonstrate that animals, or rats, were forming cognitive maps would be a big um, would be a hard thing for the behaviors to overcome, and to maintain that it's not relevant or important for learning. So let's take a look at what Tolman did. Um, so to test this theory, Tolman and his students studied 3 groups of rats learning a maze. Um, the first 2 groups are basically control groups, different types of control groups. Group 1, goes through the whole set of days of running mazes without ever being reinforced. And so the behaviors would say, well, they're not going to learn very well because reinforcement's necessary for you to increase behaviors that would lead to you performing better in the maze. And group 2, they got reinforced every time they ran the maze. Like when they got to the end, there was some cheese or whatever waiting for them. I don't know what they reinforced them with. Probably some kind of food. But um, so those were the control groups. One group that went through all the days, never getting reinforcement. The other one always got reinforcement. And then this third group was the real experimental group. They would go the first 10 days, just like group 1, receiving no reinforcement. And then starting on day 11, they would start getting reinforced. And the important question was, would rats learn the maze even if they were not receiving reinforcement for doing so? The behaviorists would say, no, if you're not getting reinforcement, you're not going to learn the maze. Well, let's look at the results. So we're going to start with the two control groups, and they performed exactly how a behaviorist would have guessed. Group 1 is in green, and you can see that they are making a lot of errors. Higher up on the graph means more errors. And you can see like they improved a little bit between day 1 and day 17, but they still were making a lot of errors even at after 17 days. Group 2 was the other control group. They always got reinforcement, and as expected, reinforcement does help you learn things, and they steadily declined. Between day 1 and day 17, you can see that the blue line is going downwards most of the time. So those would be considered normal kinds of results. But once again, the interesting group is the experimental group, colored red, and so they go 10 days, the first 10 days, in the same condition as group 1, who got, they're not getting any reinforcement. So you can see they match up pretty well with the green line up until day 11, that dotted line. And so they're making a lot of errors as well. And, group 2 is far below them because they're getting reinforced, so they're learning the maze. So, if you just look up to day 11 of behaviors and say, well, this is what we expect. So all of a sudden on day 11, the experimental group 3, they get a reward when they get to the end of the maze. And lo and behold, the very next day, on day 12, their performance increases dramatically. They at day 11, they were still making an average of 6 errors, which was their best day up to that point. And then all of a sudden, they go down to about 2 errors. And they actually start performing better than the group that had been reinforced the whole time. And you can't learn these mazes in one day. I mean, it takes multiple trials to learn the maze. But all of a sudden, when it mattered to them, when there was a reward for them to get to the end, they showed, hey, we know this maze. We knew this maze all along, or we've already learned this maze, and now we're demonstrating it. And this was the point. Like you can't explain that sudden drop any other way except those group 3 rats. They had really been learning the maze. They had formed cognitive maps, and but it just there was no incentive for them to get to the end, as quick as possible without errors. All of a sudden, as soon as there was incentive, they demonstrated, hey, we do know this maze. We have learned it, even though we haven't been reinforced for all those, first 10 days. We weren't reinforced, but we know the maze. And so this was a clear demonstration that the group 3 rats were learning even without reinforcement. They had really had learned the maze, and then as soon as there was a reason to show it, they demonstrated their knowledge. I always kind of like that. I thought it's a very clever and interesting kind of study that Tolman did here. Um, so Tolman's study demonstrated what he um, called latent learning, or learning that takes place in the absence of reinforcement. And so this research challenged radical behaviorism and implied that thinking does play a role, at least in some forms of learning. Um, and this, we're kind of going back in history. I mean, like it's well accepted now that yeah, thinking is important for various forms of learning. Not all by any means. I mean, the operant conditioning is a real thing. Classical conditioning is a real thing. We do learn a lot of things like just like animals do, and kind of in automatic ways. But there's been lots of demonstrations now that your brain plays a role in learning. Okay, let's move on to the last set of topics here. There are three ways to learn that you learn by watching others: uh, observational learning, modeling, and vicarious conditioning. Let's take a look at each of these. So, observational learning is the acquisition or modification of a behavior after exposure to at least one performance of that behavior. So, you're learning by watching. Children can learn basic skills by watching adults perform those skills. And this is, one of the ways we transmit knowledge from one generation to the next is that children often are curious and they do watch adults, um, uh, you know, perform various behaviors. Some examples of things that children are going to learn by watching adults: they'll learn what foods are safe to eat. If you watch your mother or father, eat some food, then you know that you're good to go. You can go try it too, even if you've never had it before. You learn certain objects and situations to fear. So if you see that your parents are avoiding something that might be dangerous, and you learn to avoid it as well without having to try it yourself. So it's a powerful adaptive tool, uh, observational learning. We watch those that are older and know more than us while we're developing and growing up, and we learn from them just by watching. They don't have to tell us everything in words. Okay. Um, so a classic study was Bandura's Bobo doll study, which involved observation of aggression. And what Bandura did was he brought in a bunch of preschool children and he divided them into two groups. And group one watched the film, of an adult playing quietly with Bobo. Bobo's an inflatable doll. We'll see it in a picture soon. Group two watched a film of an adult attacking Bobo, playing very roughly and hitting it and kicking it and things. And so both, and it was the same. I believe they used the same adult in both. Actually, I don't remember for sure. I would expect they did, but it doesn't really matter. But anyways, the results were the group that watched an adult, you know, behaving aggressively with the Bobo doll, they were more than twice as likely to play aggressively when they had a chance themselves. And they weren't given instructions to copy the adults or anything like that. The children were free to play nicely or to play roughly with it. Like, you know, it, and there was actually other toys they could choose to play with as well. But what was clearly demonstrated was these children that watched an aggressive adult, you know, beat up on this doll, they really learned a lot of moves from this adult, and they were ready to go copy them and be aggressive themselves. We can see some of it in the pictures here. Um, that's the adult model in the top. I'm going to zoom in just okay, so there's this woman, but just look at the similarities. So we're going to see a woman, then we're going to see a preschool boy and a preschool girl. These were both in the group that watched her be aggressive. So watch how closely they copy her behavior. So she's sitting on it and pounding on it with her fists. He sits on it and pounds on it. She sits on it and pounds it. She throws it up in the air at some point, and this kid's copying her behavior, throwing it in the air. So is the little girl. And once again, these are just preschoolers, and it's not like they watch these behaviors multiple times. I mean, this is just one film that they watched. So she's hitting it with a hammer here, and so he picks up a hammer and hits it, and she's hitting it with a hammer. Here she's kicking it. And you see he's kicking it and she's kicking it. So and this was just there was lots of subjects, but these were a couple of the ones that were clearly copying behaviors, and it really made the point that we can learn aggression by watching, as children, as young children, by watching adults behave aggressively, which has a lot of implications for, watching violent television or violent cartoons or playing violent video games. And, and also, what you're learning when adults within your home or may show some violence. Like it was a clear demonstration that the kids were learning aggression, and this was just within one day period of watching one film, they all of a sudden demonstrated all this aggression. Okay, I'm going to move on. So that's observational learning. Modeling is the second way we learn by watching others. It's the imitation of behavior through observational learning. So this involves observational learning as well. Way back when we started this chapter, I mentioned that there's a lot of overlap between these three ways that we learn by watching others, and so modeling means that you're actually imitating the behavior. So not only did you learn it, in your mind, but you're actually performing the behavior. So these, oops, I didn't mean to do that. Okay, meant to go backwards here. These kids here, not only are they demonstrating observational learning, they are actually demonstrating modeling as well. Even though it's in the first section here, they're modeling the behavior that they witnessed the adult do. Okay. We are more likely to imitate actions of attractive high status models who are similar to ourselves, such as, like if there's actors or like people on TV that are famous or that you look up to as a kid, or and so, or superheroes or whatever, or some people directly, that if they're important to you and you respect them. I mean, we want to be like the people that we look up to, so they're the ones that we tend to copy. Babies also frequently show learning by watching and then imitating behaviors and expressions, and you can see that in this figure here, the baby performing some imitations of the adult there. I will mention there's some controversy over the results of the babies, but I'm not going to get into it. This I'm not going. I want you to read this. Don't on your own. It's interesting. I'm not going to cover it myself though. So it's about, does playing violent video games cause children to become more violent? So it's a very serious issue. It's one that's been studied a lot. Go ahead and read what they say about this. It's in your book. I didn't mark the page, but you can find it. So read it on your own. So much of the research on observational learning focuses on negative behaviors, such as learning aggression, because in some ways that's more important. I hate to say that, but that's what people are most concerned about, like our kids learning aggression by watching it on TV or by playing violent video games, and so more research gets focused in that area. But observational learning can also be used for learning pro-social behaviors, meaning helpful, good behaviors. Evidence indicates that watching shows that model pro-social behaviors, such as the very high quality shows Sesame Street or Mr. Rogers' Neighborhood. Um, they help children learn how to behave for the benefit of others. And there has been a ton of research done ever since Sesame Street started so many years ago, um, showing the benefits that children get from watching Sesame Street. It really is a high quality show. Mr. Rogers' Neighborhood um, is also always highly ranked as far as um, a very good show to expose children to, and there are others as well, newer ones that are also good. But it is good to be a little bit picky and choosy maybe about which shows you want your children to watch. I remember Dora the Explorer was a very good show with positive messages. I guess there's Mr. Tagger's Neighborhood or something like that. I've heard is good. I don't know a lot of it, but there's a difference between shows like that and watching like um, Power Rangers or Ninja Turtles. And I'm reaching back sometimes because I don't I'm not exposed to a lot of the newer shows that may be out now, but those are a couple of the ones I remember. They were very violent and didn't have positive messages. Okay, this will be our last slide of this module in this chapter. And this covers the third type of learning, vicarious conditioning, or third type of learning by watching others. Vicarious conditioning, it's learning the consequences of an action by watching others being rewarded or punished for performing the action. Um, Going back to Bandura's Bobo doll study, he had conditions in his study where the preschoolers witnessed the aggressive adult model either being rewarded or punished for their aggressive behavior. So after they watched the film of her, beating up this Bobo doll, there was one condition where another adult came in and said, "Oh, you've been very bad, with that behavior." And then there's another condition where at the end an adult comes in and says, "Oh, way to go! That was great, the way you beat up that doll," or something along those lines. So, one was praise, which is a reward. One was the, kind of a critical commentary, which is a form of punishment. Okay. So these were two conditions. And what do we find? Children that witnessed the model being reinforced were much more likely to be aggressive themselves. It's like, she did it. She's an adult. She did it and got praised. And so it must be okay for me to do it. Was probably the thinking. If they had seen the model being punished, they were much less likely to model the aggressive behavior. And finally, a key distinction in learning is between the acquisition of a behavior and its performance. So, acquisition is mentally learning a behavior, performance is actually doing it, physically performing. Um, Anyways, what they showed in that study was that all the children, whether they watched the model being punished or rewarded, all the children in both groups acquired the behaviors of the model. They acquired them. They when push came to shove, they could demonstrate them when they were offered rewards to, like, I know you don't want to be aggressive, but well, you get this prize if you show me. And anyway, so they actually all demonstrated that, yeah, they remembered the behaviors, but only the group that had seen the adult being rewarded was the one that performed the behavior, that actually carried out the actions. And so this was a clear demonstration that, yeah, vicarious learning is we really do pay attention to whether others are rewarded or punished for their behaviors, and it has a big impact on whether or not we repeat or model their behaviors, ourselves. Because the group that had seen the adult rewarded, they were really the only ones. It was a very clear difference between the two groups. They were the ones that actually performed the behaviors. The ones that had seen the adult punished They knew the behaviors but did not perform them, because seeing, it was a demonstration, seeing her punished, that these are not good behaviors to do. Anyways, that I think is going to wrap it up for module 4.